Assalamualaikum warahmatullahi wabarakatuh and a very good morning. So for this video, we are going to learn how to determine if the series converge and diverge using a few tests that will be covered in this chapter. So before we go through all the tests, let us recall back what is the partial sum of the series, because we will be using the partial sum of the series in the definition of the convergence and divergence of an infinite series. So the partial sum of the series can be defined as follows. So the first partial sum of the series can be determined based on the first term of the sequence. Okay, and the second partial sum of the series is equals to the first term plus the second term, and the third partial sum of the series, it is equals to the first term plus second term plus the third term. So this followed by until the n partial sum of the series, where it is actually the expansion of the first term plus the second term plus the third term up until the nth term. Or we can represent this series in terms of the summation notation, where we can rewrite this as A sub I, where I start from 1 up until n. So all these partial sum of the series form a new sequence, where we can represent it as S sub n, where n start from 1 up until infinity. So for the definition of convergence and divergence of an infinite series, if the sequence of these partial sums, which is S sub n, converge to a number L, then the sum of the series converge to L. But if the partial sum S sub n diverge, then the sum of the series diverge. So in order to determine if the series converge or diverge, here are the list of tests that will be used in this chapter. So the first test that will be used is to determine the convergence and divergence of a geometric series, then followed by the convergent test. The third one is divergent test. The fourth one is the integral test, and the last one is ratio test. So these are the tests that will be covered, that will be used in this chapter. Only these 5 tests. So for the first test that will be covered is based on the geometric series. So geometric series is a series that is defined by common ratio in order to get the next term. So it is important to know the common ratio in order to determine the convergence of the series. So the geometric series in terms of AR to the power of n minus n, where n start from 1 up to infinity, is said to be converged if R is between -1 and 1. So if it is between this range, then it means that the series is converged. Then we can find the sum of the series, which is using this formula, which is A sub 1, 1 minus R. But if our common ratio is greater than 1 or less than 1, then the geometric series is said to be diverged. So now we determine whether the series converge or diverge. So if it converge, give it sum. So we expand the summation of the series where n is start from 1 here. So now we can write it as 1/3 to the power of 1 minus 1 plus 1/3, n is equals to 2, n is equals to 3 up until infinity. Then we can rewrite this as 1/3 to the power of 0, which is equals to 1 plus 1/3 plus 1 over 9 and so on. Okay, from here we can find the value of the common ratio, which is equals to 1/3 over 1, which is equals to 1 over 9 over 1/3. So all this becomes 1 over 3. So our common ratio is between 1 and -1. So therefore, if it falls between this range, then we can say that the series is converged. So since it is converged, then we have to find the sum of the series, where it is equals to A1 over 1 minus R. So our A1 from the series is equals to 1 over 1 minus R, which is 1/3. So we have 1 over 2/3, which is equals to 3 over 2. So this means that all the summation of this is equals to 3 over 2. Now let us try the next example. So given the series is already in terms of the series, not in terms of the summation. So what we need to do is just find the common ratio R. So we have here is -half over 1, which is also equals to 1 over 4 equals to -half and so on. So this is equals to -half. So our R is also between 1 and -1. Therefore, we can say that the series is converged. So since it is converged, then we have to find the sum where we represent as S. So this will become A1 over 1 minus R. Our A1 is equals to 1 over 1 minus R is -half. So this will become 3 over 2 to 3. So the summation of the series is equals to 2. Okay, now we proceed with another task, which is convergence. So given an infinite series, where the series is given as the summation of A sub R, where R start from 1 up to infinity is equals to this. Okay, and the end partial sum Sn is equals to the summation of the series from 1 to n. So if the sequence of the partial sum is convergent and the limit of the partial sum is equals to S, where S exists as a real number, then we can say that the infinite series of AR from R equals to 1 up to infinity is converged. And we can write the summation, the series, which is equals to S, or the summation of AR is equal to S. So the value of S here is called as the sum of series. If the summation or the limit is not exists as a real number, so we can say that the series is diverged. Okay, now let us consider an example for convergent series. Given the summation of 1 over 2R from R is equals to 1 to infinity, given the expansion of the series is in terms of this. So we found out that the series is in a geometric series. So same like the previous topic, we can find the sum of the series where R is equals to half. Then we can find the sum of the series which is equals to 1. So it means that the series here converge to 1. Okay, now we go through to the next test, which is divergence test. A divergence test is said to be the summation of AR, where R equals to 1 up to infinity, is said to be converged if the limit of AR as R approaching infinity is equals to 0. But if the limit of AR not equals to 0, or the limit of AR as R approaching infinity does not exist, it means that the series diverge. So in order for you to understand this, let us try example. So determine whether the following series diverge or converge. So by using divergence test. Okay, so now what we have here is the summation of r squared over 5r squared plus 4 as r is equals to 1 up to infinity. Then we have to find the limit of the series. So we write down back our r squared over 5r squared plus 4, where r is approaching infinity. So if we substitute infinity into this series, we will get this into this fraction. We will get it in terms of infinity over infinity. So for this indeterminate form, we need to apply the L'Hopital's rule. So now what we have to do is we just find the derivative of the upper part, which will be 2r, and over the derivative of the lower part, which will become 10r. So now still the fraction becomes infinity over infinity. So it's still in the indeterminate form. So next we apply the same rule, which is L'Hopital's rule. So we find the derivative of the upper part, which is 2, and the lower part is 10. So now we have our limit is equals to 1 over 5. So 1 over 5 is not equals to 0. Since it is not equals to 0, so according to the divergence test, since the limit is not equals to 0, it means that the series diverge. Okay, now we proceed with the next example. R is R over 2R plus 1. So we apply the limit, write back the fraction r is approaching infinity. So our limit is the same, which become infinity over infinity. So we apply the L'Hopital's rule here. So we have this become 1 over 2. So our limit is equals to half. So it is the same where it is not equals to 0. So the series diverge. Now let us proceed with the next example. So same, you can try this first. You can pause this and try to determine whether the series converge or diverge. Okay, now I hope that you have tried, and let us check your solution and my solution. So first what we need to do is write the limit 1 over r cubed. R is approaching infinity. So what we have here is limit of r approaching infinity. This will become 1 over infinity. So this as the limit approaching infinity for 1 over infinity. So the answer will be equals to 0. So as the limit is equals to 0, it means that the series converge. Now we proceed with another test, which is integral test. So since it is called as integral test, means that it involves the integration. So suppose that the function of fx must be a continuous, positive and decreasing function on the range between 1 up to infinity. And we let a sub r equals to function of r for r equals to 1, 2, 3 and so on. Then the series of AR as r equals to 1 to infinity is converged if and only if the improper integral of fx dx, where the limit is from 1 to infinity, converge. Or in other words, we can say that if the integration of fx dx from 1 to infinity converge, then the series of AR converge. If the integration of fx dx from 1 to infinity diverge, then the summation of r equals to 1 to infinity diverge. So this is the integral test. So now let us use this integral test to determine the function of ln r over r converge or diverge. So the first thing we need to look at is we need to change this ln r over r into the function of x. So our function of x now becomes ln x over x. So we have to check whether this function is continuous, positive or decreasing or not. So if you refer to this graph, this is the graph of ln x over x. So it is said that the function must be continuous at the range of between 1 to infinity. So if you can see here, this is when x equals to 1. So from 1 to infinity, you can see the value of the function is positive, meaning that it is up, it is more than 0. Okay, and then it is continuous, meaning that there is no discontinuity in the interval from 1 to infinity. Okay, and also you can see here is the function is decreasing. Okay, now what we can do is we can solve this series using the integral test. So we can write it as ln, and write it as the integration of 1 to infinity of ln x over x dx. Since it is the interval involve the infinity, then it is improper integral. So we have to write the limit where the range is from 1 up to t as t approaches infinity. Ln x over x dx. Then we solve the integration of ln x over x dx by using the integration by substitution, where we let u equals to ln x and our tu will become 1 over x dx. So we have represented our ln x as u and our dx over x as du. Now our integration become u tu. So now we can solve the integration, which become u square over 2 plus c substitute u with ln x, we have ln x squared over 2 plus. Now we can substitute into this. We have ln x squared over 2 as the limit is from 1 to 2. Substitute x with t, we have ln t squared over 2 minus ln 1 over 2. So now this become 0 and this become infinity. So the integral shows that the integral is equals to infinity, meaning that the series diverge. Now we have come to the last test, which is ratio test. So a ratio test, let the infinite series of r equals to 1 to infinity with positive terms, and we let rho equals to limit of ar plus 1 over ar as r approaching infinity. If rho is less than 1, we say that the series converge. If rho greater than 1 or rho is equals to infinity, we can say that the series diverge. And if rho is equals to 1, we say that the test is inconclusive. It means that the series can be converged or diverged. So if in case you get the value of rho is equals to 1, then just write down that the test is inconclusive. Now let us try this example to show you how to use the ratio test to determine the series converge or diverge. So what we need to do is we write down our AR, where AR here is given as 3 to the power of R factorial. The next thing is you have to get the rho, which is the limit of AR plus 1 over AR as R approaching infinity. So the next thing you have to do is you have to find the AR plus 1. So now what we can get from here is that 3R now is become R plus 1. So this become 3R plus 1 over R is now become R plus 1 factorial. Since we have function of AR plus 1 and AR, then we can substitute into the limit. So the limit of AR plus 1, which become 3R plus 1 over R plus 1 factorial, divide by AR, this become 3R over R factorial. So if we rewrite back, we simplify this, come, so this will be multiplied with R factorial over 3R. R is approaching infinity. Now our rho is becomes limit of this. So first we simplify 3R plus 1 over 3R. So we can bring our 3R to the upper part. So this will become 3R plus 1 times with 3 minus R times with R factorial divided by r plus 1 factorial. Okay, now I try to solve the first part here, where this will become 3r plus 1 minus r. So final answer will be 3 to the power of 1. So left is 3. Okay, next is our r factorial over r plus 1 factorial. If you notice, what does it mean by r factorial? It is equals to, okay, let's say I give you an example, which is 3 factorial. So 3 factorial means that it is the multiplication from 1 times 2 times 3. And for 4 factorial, it is 1 times 2 times 3 times 4. And n factorial, it is 1 times 2 times 3 times 4 up until n. Same goes with r. So the multiplication will be from 1, 2, 3 up until r. And same goes with r plus 1. So r plus 1 meaning that we can multiply from 1, 2, 3 up until r times with r plus 1. So if r factorial divided by r plus 1 factorial, it means that we can cancel 1 up until r multiplication with the below part. So what is left is just 1 over r plus 1. So here it becomes 3 over r plus 1. So substitute r with infinity, we will have 3 over infinity, which will become equals to 0. So since rho is less than 1, means that the series converge. So that's all for the convergence and divergence test.